Hello, everyone. Welcome to my name is Jason Von Ruden, and welcome to the Wisconsin.net user group, where we do monthly meetings to cover the latest technologies, including web, mobile, cloud, .net, and more. Thanks for being here. I also have a few announcements. Next month, we'll have a talk on building your .net services using gRPC. We're looking to do in-person and hybrid, so that's an announcement for next month where we're going to start going in person more and still do the hybrid streaming as well. So thank you. Tonight we'll have a talk on Don't Build a Distributed Monolith, Avoid Doing Microservices Wrong by Jay Tower. I want to thank Jay Tower for speaking with us today.
All right. Thank you very much, Jason.
All right.
All right, let me share my screen here. Make sure I get the right one. Okay, hopefully everyone should be able to see that in just a second here.
All right. There we are. I think
awesome.
we have that. So thank you very much, and take it away.
All right, thanks. I will do that. Thanks, Jason. Thanks, everybody. Maybe I've met some of you before, maybe some of you I'm a new face, but I'm just over here on the other side of the lake in Michigan, in the other Great Lakes state. So it's nice, always nice to visit, even if it's just virtually with my friends in Wisconsin. Hopefully, now that you guys, it sounds like, are going to be starting to meet back in person, I could join you again in the future at some point in person. That would be great. Tonight, as Jason mentioned, we're going to talk about don't build a distributed monolith, how to avoid doing microservices completely wrong. My name, again, is Jonathan Tower, and I go by Jay for short. So recently, a client came to us, and they had this application that they had just about finished building. They said they were just about to launch it, and that they had built this application using microservices architecture. And at least according to them, they had just a few performance problems that they'd like some help in, ironing out before they went live. But it really only took us a few minutes of looking at their code, looking at their system architecture, to realize that they actually hadn't built microservices, and that they would probably need to completely re-architect this application to be able to fix these performance problems, which were much more widespread than they had led us to believe, because instead of building nice, clean microservices, they had actually built a distributed monolith. So that's what we're going to talk about tonight. What is a distributed monolith? How is it different from microservices or a monolith? And how to avoid building it, because it is definitely the bad guy of our story tonight. So this is far from the only distributed monolith that we've seen that started out as an attempt to build microservices. So in this talk, I want to show you 12 of the most common mistakes that I've seen software teams making that have turned their microservices projects accidentally into a distributed monolith. Before we get started, my name is, as I mentioned, Jonathan Tower. I go by Jay for short. I'm located in Michigan. I'm an 8-time now MVP and Microsoft MVP in .NET. I'm also a founding partner at Trailhead Technology Partners, where we help our clients build custom software, such as building microservices. I've got nearly 25 years of professional experience, and I've either seen in that time or made just about every architectural mistake that can be made. And so tonight, I'm hoping that I can share some of that experience with you as it relates to building microservices correctly. Before we get right into it, I want to just call out this little thing I like to do in all of my talks. If anyone has seen one of my talks before, maybe you remember this, but I like to do this speaking in the community as a way to give back. There's been a bunch of people over the years who've fed into my life or my career, and instead of paying them back, I kind of see it as a way to pay it forward by sharing what I've been learning with others in the community. But in a sense, we're all very lucky to be in the industry we're in. We all make decent money. Hopefully many of us even have some disposable income, but there's about 1 billion people, just under 1 billion, who don't have access to clean water. Causes them all kinds of problems. Poverty is definitely related to that. Obviously health is definitely related to that. So as a way that we can kind of all pay it forward, I like to do this in all my talks. If there's something useful you hear tonight, if there's something interesting, saves you some time, funny, anything like that, that you want to go ahead and pay that forward, you can go to this bit.ly link, whisk-water. That's WISC-water. And, or you can go to this QR code, and I've set up a little fundraiser there for one of my favorite charities that's addressing this clean water crisis called Charity Water. It's a fantastic charity if you want to look into it more at some point. So bit.ly/whiskwater. And if you all give $200 while I'm talking tonight, then I'll put my money where my mouth is and do the same and match that $200. So be kind of a fun way to do that together. I like to always joke too that if you find this to be a complete waste of time, or you totally disagree with something that I say and you want to punish me, a great way to do that would also be to go give some money to this charity and cost me $200 as a punishment. So either way, make sure you do that. So let's start out with some definitions. First of all, what's a monolith? Well, monolith is just this architecture, sort of a traditional unified model that we've been using for many decades to build software applications. Typically, the components of a monolithic application are more interconnected and interdependent on each other rather than being completely loosely coupled. Each component then has to be present in order for the whole application to be compiled and executed, and it's usually then deployed as a complete whole. There's advantages and disadvantages to a monolith. I think if you go to a lot of talks that are about microservices, you'll see the monolith kind of used as an example of what not to do. And that's true, obviously, if you're trying to build microservices. But I want to just, if there's only one thing you take out of this talk tonight, I hope it's that monoliths aren't inherently bad. There's a good way to build monoliths, and there's some projects that are a better fit for monoliths, and there's a bad way to build monoliths, and we probably all have seen that or experienced that. But there's also some disadvantages to microservices, the alternative to the monolith. So we're going to talk about those. Hopefully by the end of my talk tonight, you'll be very well versed, if you're not already, in what those advantages and disadvantages are. Some of the advantages of the monolith: it is much easier to create, to build, to program a monolith than it is to create a microservices architecture correctly. They typically have better data throughput. I don't mean always performance in general, but I mean data throughput. So that means when data is entered into the system and when it gets, and how long it takes to get distributed throughout the system. That is typically instantaneous in a monolith, and that is something that is not true in a microservice. A lot of people think of microservices as being more scalable, and they certainly are scalable in ways that monoliths are not, but monoliths are also scalable through things like load balancing and data sharding. There's a lot less cross-cutting concerns when you're building a monolith. If you're thinking about things like logging, that's a lot more complicated cross-cutting concern when you're doing a microservice and you have tons of independent services that all need to somehow use the same logging. And then the last advantage has to do with that data throughput I mentioned, which is this concept of immediate consistency. In a monolith, when someone updates some data, the entire application immediately is consistent. That data is the same everywhere in the application. Of course, there's disadvantages with a monolith. You have to update the entire application, even if there's a small change. We've probably all done this before on a monolithic application, where you're just, say, changing a button name or something very simple like that, a navigation text or some other static text or something like that. And even though it's a very small change, you have to build and redeploy the whole application because it's a monolithic application, has to be deployed together. Typically, there's going to be tighter coupling in a monolith between your components, which means it's easier to accidentally write some bad code in one module and have that break multiple different modules. Often a monolith has to be written in the same technology stack, across the board. That makes it a little bit less agile. when you're trying to make updates to a monolith than it is in microservices. And then the last one is that if you have small teams that want to be really focused on just one area of the business, that's a really good fit for a monolith. I'm sorry, for microservices, and not a great fit for monoliths. But if you have a big team that wants to kind of work a little bit on everything, then that might be a better fit for monolithic applications. So we'll talk about those more as we go. Typical monolith is going to look something like this, where you have client applications or browsers or users accessing a middle tier of your application, and then that application is using a backend data store like a relational database or document database or something to store that data, read and write that data from. If you do want to scale your monolithic application, I mentioned that you can do that lots of different ways. One of them is something that is called vertical scaling, and that's when you actually add more resources to the existing entities that are part of your application, the existing computers or servers or cloud resources. And vertical scaling is things like adding more memory, more processing power, etc. So you can kind of imagine making that like a bigger, beefier server for your application tier. And that would be considered vertical scaling for a monolith. You can vertically scale your database tier as well if that becomes your bottleneck at some point. You can do it the same way. You can add more processing power, faster disks, more memory. All of those things are going to make a database work faster or work for more concurrent load. And that would all be scaling vertically. You can also scale horizontally in a monolithic application. Typically, that's done in the middle tier of your application using something called load balancing. Probably all seen this before if you have a web application or a web API application. That application basically be copied onto multiple servers. There'll be a load balancer device put in front of it that basically just takes the traffic and then round robins that traffic back and forth between the servers. So if you add a second server, you can get almost twice the number of concurrent users until you hit some other bottleneck like your database. And that is one example of scaling horizontally. You can also scale horizontally at the database layer if that is where your bottleneck is in your monolith. You do that typically through something called data sharding. And data sharding is where you basically take your data and you split it based off of a key. Most often that works really well in applications where there's different users or different accounts or different tenants within the application, and where each of those tenants' data never really talks to each other or crosses at all. You can imagine, a lot of the online services that you sign up for, you might interact with other people within your same organization's data, but you never interact with data for people in a different organization. So in that case, the tenant would actually be your organization's ID. You could split that data so that, multiple organizations are in one database, and then another chunk of your organizations are in a second database. Eventually, you could add a third database and put more organizations in there. And then basically, you're just routing traffic to different databases depending on which organization a user is affiliated with. So another way to scale horizontally in your data tier of a monolith. Okay, so that's monoliths. Now let's talk about microservices. This is kind of that holy grail. We hear people talking about this a lot right now. This is the hot buzzword in our industry. These microservices are when you deploy multiple independent services that are not coupled to each other at all. And you do that usually by splitting your application up into separate domains that don't relate to each other as much as the stuff that's within them does. This allows you to have some benefits like independent deployment. You can deploy microservices. You can update one microservice without having to touch the others. Some more precision to your scalability. So all that scaling we just talked about is also true with microservices, but you can target it to specific microservices. So imagine you had a hotel system where you've got an authentication service and a booking service. So let's say your booking service gets hit a lot more than your authentication service. And that is really the bottleneck for your application. Well, you can scale just that service horizontally or vertically and add a lot of additional users concurrently to your application without having to scale all those other microservices like the authentication one. High availability, if one of your services goes down for maintenance or some sort of an error, that doesn't bring down any of the other parts of your service. So a lot more fault isolation between the different parts of the application in a microservice. You can also use different technologies. This is one a lot of people don't think about when they're thinking about microservices. But if you have a large organization and there's different teams that are kind of focused on different parts of the organization, and maybe different teams have different technology preferences, or maybe they're integrating into different systems where different tech stacks would make more sense. Maybe you've got a Java team that wants to integrate with some Java systems and write that part of your application. You got a .NET team, you got a Node team, etc. You can do that with microservices. That's a lot harder to do if you're building a monolith. It also allows for more agile processes because everything is built loosely coupled. You can update things very frequently. You could do daily releases if you wanted to. It would be a lot easier. You could do hourly releases with microservices, which is much harder to do with monolith without having downtime. And then finally, I mentioned this earlier, but you can have smaller teams that are just experts in different domains, different parts of the business, and really focused on just those domains. There's disadvantages. I mentioned some of these earlier. It's really easy to do wrong and accidentally build something much worse than a monolith or microservices. It oftentimes requires you to reorganize your teams to kind of fit the microservices. We'll talk about that more. Debugging and monitoring can be a lot more difficult in microservices because it's a distributed system. And then there's this huge trade-off. I mentioned immediate consistency as a pro earlier for monoliths. And for microservices, you have the opposite of that, which is eventual consistency. If one microservice gets some updated data, that data needs to travel through the whole system and eventually get updated in all of the modules that care about it. But that might take some time depending on how busy the system is. And during that time, you'll have some inconsistency between your data throughout your application. So if that's not a good fit for your application, then definitely don't consider microservices. This is a typical architecture of what a good, well-architected microservice application might look like. I'll just mention here under the client layer, you see there's a layer with something called an API gateway. There's a lot of different ways to do this. This is often a way to kind of bring together different sets of endpoints that are from different microservices and to present them as a unified whole to a front-end application. So you could kind of mimic as if you had a monolithic API to different front-end applications by just presenting them with the APIs that they need. There's also some like security that could be brought together in this API gateway. And there's a lot of advantages to that. It's a very common technology to have in your stack when you're doing microservices. Then the important part about microservices is you note here these 5 individual columns with a application layer and a database layer. And you notice that there's no arrows between any of those. That's a really important distinction for a well-architected microservice, is that these microservices are not talking to each other directly, reading each other's data, sending each other updates, reading data from each other, etc. None of that stuff is really happening directly. Instead, what's happening is they have an event bus, which is that last layer in this model. And they're basically using that event bus as a way to do publish and subscribe style notifications or messages to each other. So if some data gets updated by the first microservice here, and one of the other microservices cares about it, then this first microservice will publish an event to the event bus, and then whoever cares about that will have subscribed to that event. We'll go ahead and read that event and update its own copy of the data. So that's kind of that eventual consistency that we talked about. So that's a well-architected example of a microservice. Now let's talk about the bad guy from the title tonight, which is the distributed monolith. So what is this? Well, this is when you have highly coupled modules that have been distributed separately. So if you write your application like it's a monolith and then try and kind of chop it up and distribute it separately. Now you might think, well, who would do that? And the answer is nobody does that on purpose, I don't think. I haven't run into anyone yet, actually, who's done that on purpose. But I have run into almost everyone I've run into who's tried to build microservices, at least their first time, they did do this accidentally. And so that's why I created this talk. That's why I want to go through these 12 examples with you tonight, so that you can maybe avoid some of those pitfalls. The thing is, when you set out to build microservices, most common result is for it to end up being distributed monolith accidentally. When you do that, you don't get the benefits of microservices or of monoliths. In fact, you get kind of the worst of both and the best of neither. The performance and maintainability are both very difficult. And that is from that story I told you at the beginning, exactly what happened with that client of ours. They had basically built it this way. We started by actually, we started helping them get to microservices by first re-monolithing their application, because it was already much closer to a monolith. And so we actually just took out a lot of the pretense of microservices and made it a monolith, and then helped them separate it correctly later. So that's a distributed monolith, and we definitely don't want to build that. So you might be wondering, what's a distributed monolith look like? Well, I left out the event bus layer. A distributed monolith could still have an event bus, but I've just left it out because it's not super important. What I really want you to focus on in this diagram is those individual columns of microservices that have all these red lines between them. This is really what happens when that causes you to build a distributed monolith. You'll notice that some of these are calling each other's databases. Some of them are calling each other directly at the service layer. It might feel like that's the right way to do it when you're doing it, because it feels like I shouldn't, I've learned all these things over the years about not repeating data, like normalizing my data. I've learned all these things about not repeating myself and single responsibility principle and all these great software architecture things. And a lot of those, you actually have to go against what you've learned for many years and do the exact opposite to do a well-architected microservice. So in these cases, these are the types of things that I see all the time, where developers are trying to follow those good practices that they know from monoliths, and then it forces their hand to kind of make it a distributed monolith. So we don't want those red arrows in our applications. The other most popular way I see of accidentally creating a distributed monolith is this. So they've created it as a microservice all the way down until they get to the database. And then more often than not, what happens is somebody, often like someone in charge of the database, let's say, will say, no, everything you developers are talking about sounds like the worst possible design decisions I can imagine. I've been, working at this for decades, and I know that I'm supposed to normalize data. I'm not supposed to have repeating data. Having data that is all chopped up into different applications and there's different little mini applications and is repeated. That sounds like an absolutely terrible architecture. So why don't you guys just go ahead and do, whatever crazy little architecture you want to do, but we're going to still keep the database as this unified whole with everything, perfectly designed and normalized in it the way we've been doing for decades. The minute you do that, now all these different applications can access each other's data, and it really couples them together, and you really have a monolith again, just a much more difficult to build monolith, and a much more touchy, easy to break, fragile monolith. Okay, so that's kind of a quick overview of those three different types. I want to talk now about how they kind of relate to each other. The way I think it's most important to think about them is on these two axes. One of them is how physically separated they are, and the other one on the bottom there is how logically separated they are. So I mentioned there's such a thing as a good monolith. That was this one we were just talking about over here. And there's also such a thing we all know from experience probably as a bad monolith. Those are often referred to as a ball of mud monolith. And that's because you really, everything is so interdependent and coupled to each other between the different modules that you really can't change anything without breaking something else. You have a ball of mud monolith if you go in to fix one bug and it breaks two or three other things that seem like they wouldn't have anything to do with that bug that you were fixing. That kind of fragility, difficult to administer, difficult to change, type of architecture, that's a really good indicator that you have a ball of mud. So that's a logically monolithic application that's been written very connected and coupled, highly coupled. That's also being deployed as a monolithic single deployment. Now, if you just refactor that application significantly in many cases, you can get a nice modular application that is still compiled and deployed as a whole monolith. But then you get what's a nice, beautiful distributed monolith. These are usually a lot easier to maintain. Yes, you have to take the whole system down if you're doing like a big update because it's a monolith. But usually it's much easier to maintain. You can go change something in one area without affecting something in another area. Much more low coupling and high cohesion. And then if you get up to the top right corner here, that's where we get to our holy grail, which is this true microservice architecture. This is when you write your applications as extremely modular logically. So they have really no relationship to each other logically at all. And then they're deployed also as multiple physical deployments. And so they're physically and logically modular. And then the last one, the bad guy of our story, the distributed monolith. This is when you logically couple everything in your application the same way you would in a ball of mud monolith, and then try to kind of arbitrarily split it up and deploy it to multiple deployments, multiple microservice destinations. And they all relate to each other. They all talk to each other. They all have the potential to be brought up, down by other components in other modules, etc. All of those things indicate that you have a distributed monolith. Now, if I was going to build one of these, I would say to build microservices or the modular monolith. And that really is going to depend on that eventual consistency that we talked about. Does your application allow for eventual consistency? And there's a few other things that we're going to talk about tonight too that make it a good or a bad fit for microservices or monoliths. And what I would say is you shouldn't build either of the distributed monolith or the ball of mud, but in many ways, you'll at least have the potential for a functional and performant application if you build a ball of mud. If you take that ball of mud and distribute it as a distributed monolith, then you're going to not only have a difficult to maintain application, you're going to have a slow, difficult to maintain application as well. So that arguably is the worst option on here. So hopefully that helps you kind of map out the relationship between these different types of systems, different architectures. Let's talk now about the 12 most common mistakes that I've seen. And you can hopefully use these as a way to avoid making one of these distributed monolithic monsters. So number one is assuming that microservices are always better. This is a mistake that I've seen a lot. It's easy to do. Microservices are the buzzword right now in our industry. If you go to a conference, if you go to a meetup like you are tonight, you'll often see microservices as the topic. And the ones I've sat in are often kind of, rah-rah about microservices and only have bad things to say about monoliths, which is why I wanted to kind of talk a little bit about how there's such a thing as a good and a bad fit for a microservices project. One of the lead thinkers, in fact, in this space is someone named Sam Newman. You may have heard of some of his books that he's written about microservices. He says that if you're going to architect something as microservices, that before you do that, you should have a, quote, really good reason for doing that. There's this binary thinking, I think, maybe because of it being a buzzword right now, that monoliths are the opposite of microservices. And so microservices are good and monoliths are bad. But Sam Newman actually says that you should be really slow to decide and methodical, maybe even to decide that you want to build microservices. A couple of reasons why. Monoliths aren't inherently bad. We just talked about you can scale them. They have some real advantages. They're actually a lot easier to build than microservices. And that microservices are really hard. It's the easiest thing to do if you're building microservices is to mess it up and build a monolith. If you haven't done it successfully before, chances are you will mess it up. And, that's what I'm hoping to help you avoid tonight. If you read Sam Newman's works, you'll see that he has a lot of different reasons that he says might be a good fit for your application to be a microservice. One of them is to reduce downtime with the high speed of deployment. I was setting in a DevOps talk recently where someone from Amazon was talking about how the Amazon.com site goes through tens of thousands of releases in a single day. And that might sound really crazy, but obviously it's a really large application. It's a really complicated application that has a lot of different components, some of which have very little to do with each other. There's parts for buying stuff, and then there's parts for like adding members to your family for digital content or things like that, right? And those don't exactly relate to each other. Those are really separate domains. And so they've built their application as a microservice, and it allows them to update it tens of thousands of times a day, which is pretty amazing, but not something that all of us need to do. Isolating specific data for data processing through data partitioning. This is something that you could think about as a real upside if your application has really separate chunks of data. An example I always give of this is like gRPC. If you have some user data and you want that user to have the right to be forgotten, which is one of the gRPC things, then it would be really easy if you had like your user system where all of that like identifiable information was in that microservice, and then just maybe like a GUID or a unique ID or something like that was tied to that from the other systems. And then it's really easy to delete that data for that user just in that one place. And then the last one is a high degree of team autonomy, Sam Newman says. So if you want separate teams that are independently working on their own release cycles, their own technology choices, all of these types of things, then microservices are probably going to be a really good fit for your team. Problem number 2 that I've seen is using shared data stores or data models. We already talked about this a little bit with the database as one of the most popular ways to do a distributed monolith. So imagine you share the data store, for example, in this case, a relational database. Anytime you change the schema of one of the services, you may end up impacting another service that's also accessing that data that you didn't know about. Hence, the services are actually tightly coupled to each other without even maybe realizing that they are. So now each service has to use the same model as each other, and each object becomes an aggregate of all the properties of all of the properties of each service for that model, whether or not a given service cares about those individual properties or not. So basically what I'm saying is if you go in and change a type in one of your tables that belongs to service A over here, and service B is cheating and looking at that data, now service B is just broken, and now you can't actually make changes to service A without potentially risking that service B is broken. The only way to make sure that you can actually do that safely is to actually have a separate data store where it's impossible for service B to access service A's data. So that's a really common way I see that mistake happening. Another one is sharing a data model. So imagine this where you've got a hotel system with a bunch of different microservices. Let's say there's one that's reservations, one that's for doing maintenance, and one that's for doing housekeeping of the rooms. In a traditional monolithic application, what we've all learned is that you create a table, you call it hotel room, you put all of the properties that are true of a hotel room on that, you create a model that maps to that table, and that model has all of the properties that you care about, or all the properties that exist on the hotel room table. So currently occupied, maybe everybody cares about that a little bit, but number of beds, that's something really just for reservations. The time to clean it, that's something that's really just for keeping, maybe there's this like related entity of repair history that's on here. That's only something maintenance would care about. So all of these fields kind of like divvy out into different microservices here. Now, if you imagine that for housekeeping, they said, we don't really care about the minutes to clean being float. We don't need to be that accurate with the cleaning times. We're going to go ahead and change that to an integer. If I was sharing this model, now I've just broken anything else that was using the same model. So I really want my reservations and maintenance microservice applications to be totally separate with their own models for the hotel room. And I really don't want them to even care about things like minutes to clean if it's not something that they're working with. So in the most simplistic scenario, I could just divvy those fields out like this, where reservation has the number of beds and whether it's currently occupied. The hotel, the housekeeping just has the minutes to clean, and the maintenance just has repair history on it. And none of those applications are really aware of the fact that there's a hotel, that these pieces of data are all about the same hotel room. They don't know any of that other, any of those other details from any of those other applications at all. They only know what they know about the hotel room. So you're probably thinking, if you haven't done microservices before, you're probably thinking, Jay, this is an idyllic situation. What about this case where housekeeping, maintenance, and reservations all need to know some piece of data about a room, like maybe it's room number, for example. And this is where, your database person is going to really shudder the first time you explain this to them. But in a well-architected microservice, that piece of data would be owned by one microservice, as in it would be edited in one microservice, but it would be copied into every other microservice that cares about it through that publish and subscribe event model. So let's say there's like an admin API. Let's say this one here is the admin API. It would have maybe the ability to add new room numbers. And when a new room got created, it would basically publish an event to that event bus we saw on our architecture diagram. And all these other modules that needed to know something about rooms would basically copy or would subscribe to that event and then create a hotel room of their own within their own data stores. And that's where that eventual consistency that I've been talking about comes in, because that might take a couple seconds. If the application's under load, it might take longer, might be almost instantaneous, but it's not going to be the same as writing it all to just one table, essentially locking the table while the update, locking the row while the update is happening, the way that we've been doing in monolithic applications for decades at this point. So it's a little different way of thinking. Problem number 3 that I've seen is failing to separate subdomains. I'm guessing we probably have some folks in the room that are domain-driven development fans. I'm not going to go into really much detail about domain-driven development because it's this huge topic that we could spend hours just on it. But if you do want to learn how to divide your application up into different subdomains, it is the best way to do it. I think it'll help you understand where to draw those lines between different microservices. And basically, it's this concept of a subdomain or a bounded context, more specifically in domain-driven development. But here's my kind of like simple way, if you don't know domain-driven development or, while you're still learning that, my simple way of thinking about it is that you want the smallest possible microservice you can build without creating chatty communication between services. Now, there's some of that is a little open to interpretation. So what I just want to point out is that you've got two things that are kind of in balance here. So we're trying to create microservices that are as focused as possible. That's what makes them micro. But we're also trying to eliminate the need to have a microservice that always has to publish everything it does so that something else can subscribe to it. That creates a really chatty microservice that is arguably too micro. So I've got an example of this later on, which we'll talk about. Number 4 problem I've seen is starting from scratch. So assuming that that is the easier way to do it is a mistake. Actually, Sam Newman talks about how it's better to start with a brownfield or an existing project that you're migrating to microservices, because there's some pretty significant advantages there. Number 1, you have all of the relationships between the different entities and modules in your application are already defined in the existing code base. And you can really leverage that a lot to make some decisions about how to split up your microservices. Number 2, if it's an application that's already running, you're going to have probably people that you can talk to about why they made certain decisions the way they did. Get some feedback about, oh, don't do that. The reason we did it this way is this thing that you wouldn't know about just by looking at it. Or maybe, yeah, we always wished we had built this differently. So yeah, please do split those things up into different services. Those are great examples of the kind of knowledge that you have when someone's already built that application as a brownfield monolithic application. Number 3 is a system that already works. This buys you time. You're trying to migrate your application to microservices. A lot of times that's considered to be like tech debt work, and that's not a new feature. It's not, it might even hurt performance for a little bit when you first start. And so it's hard to, get your boss to agree to let you do that, or to get the business to be happy with that decision, because, you're actually making things worse. Well, if you already have a system that works, you can just keep working on it until you do make it better. And that buys you some time. So that's a pretty big advantage. Another one, so you have a baseline to compare your refactorings to. So you refactor the app into microservices and you want to know, is this making the app better or not? Do I need to keep refactoring it, or have I already made the performance better, the scalability better? You can answer those questions if you have a baseline to compare it to, which you wouldn't have if it's a greenfield project. There's 3 different approaches that people usually use when they're migrating a monolith to a microservice. The first one is called the Big Bang approach. This is when you do it all at once, just get it over with, lock yourself in the conference room as a team and don't come out for a few days until the whole system is rewritten. I don't recommend this unless you're doing a really small system. If you're doing anything bigger than a very small system, this is going to be the most risky option. The best way to guarantee that you don't do it really well, or that you have to kind of rush through it or whatever. So keep that in mind. The second option is evolution, which is basically refactoring in cycles. It'll get less like microservices, then more like microservices. So you can kind of think of this as like an up and down recycling, evolutionary cycling. So maybe you refactor out your stuff into more separate modules, but that makes the performance a bit worse. So you refactor again, and that kind of improves it. And then you refactor again, that makes it a little worse. And then you refactor again, and it gets a little bit better. So this is kind of the idea of the evolutionary model. This can be a very useful approach. I've seen teams use this. I think the best approach, though, is the Strangler Fig Pattern. This is an analogy that Martin Fowler gave for a kind of gradual replacement approach. Maybe you've heard of this before. So the Strangler Fig is this, as I understand, it's this vine that exists that starts growing like in the tree's limbs and grows down the tree. Eventually it sinks roots and kind of wraps around the tree's roots and chokes them out, so they can't get any nutrients or water. That vine then basically kills the tree and is now, using the tree kind of as a backbone to reach up to that sweet sunlight. And it kind of has like replaced the tree with itself over time gradually. So the same approaches can be done with software. You've probably seen this before other places, but if you imagine creating a facade layer here, that's like your Strangler Fig facade layer, and you start with a big legacy application that's all done monolithically, and you start refactoring that into smaller, at first it'll be a small microservices application. Bring it all together in this facade layer. This could be an API gateway or something. Bring it all together so that the client applications are none the wiser. It all looks exactly the same, works exactly the same. Over time, you kind of move stuff from one side to the other. Eventually, that modern side gets a bit bigger. All the time, you're keeping that facade layer in front of it so that the API looks the same to the client applications. And then finally, at some point, you finish that migration work. Maybe it takes you a couple of years or something, but you finish it all, you get it migrated over to microservices, and you can theoretically at that point get rid of the facade layer. So that's the approach I've seen taken for anything big, and that usually is the most successful. Problem number 5 is the tight coupling of services. When you create your different services, you don't want them talking to each other. You don't want them sharing models. We've talked about that before. You don't want them making synchronous calls between each other, or even really sharing helper classes is a problem. All of these things can create coupling between the different modules in your application that you don't intend. And so really you want to kind of think of these as totally separate applications. This is a good time to actually point out that a lot of people have asked me in this talk before, should my microservices all be in one code repo, or should they all be in separate code repos? I think this right here hopefully illustrates that what my answer to that is that they should all be in separate code repos. And the reason is because if you use the same repo, even if you intend not to share stuff, it's very tempting and it's very easy to do accidentally or on purpose to share stuff if they're all together. And so if you really want to have decoupled microservices, they should each all have their own code repository, not a big monolithic repository. All right, this is a good time to kind of do a quick check of where we're at on the charity. So just a reminder, anything I've said is useful so far. Going to save you some time as you're thinking about microservices. I'd love it if you'd go to this bit.ly link, bit.ly/WISC-water, and donate a little money. I'll match that if we get to $200 tonight. I'll show that one more time at the end. All right, so problem number 6, microservices that are too small. I mentioned that chattiness problem. So we're trying to create small microservices that are not chatty. Imagine the scenario where you said, I'm going to go all in on microservices. I'm going to take every endpoint from my existing services, and each one is going to be its own microservice. That's how micro they're going to be. That might feel like it makes a lot of sense, but imagine the scenario where you took 2 endpoints from your like authorization endpoint, one for login and one for password reset. Well, obviously, anytime one of them does anything, whether it's publishing it through the event bus or whether it's doing these red lines that we shouldn't do, talking directly to each other, either way, whenever you password reset or whenever you log in, you're going to have to let the other service know. And so these services are very chatty because they don't do anything without communicating with each other. So I would argue that this is a good example of too chatty because they're too small. So you combine these into a single service. Now they have a single data store. Now when some user comes in and resets their password, the user login service knows about it instantly because it was in the same data store that the user login service is using. That probably makes a lot more sense, and it reduces the chattiness here while still having a pretty small service with just 2 endpoints in it. Another common problem I see is these cross-cutting concerns like logging. It's really hard to implement decentralized logging correctly. If you're tempted as a team to write your own, there's 2 things I always say not to write your own of when you're doing microservices. Number 1 is the event bus. There's lots of great event buses that are way better than, it seems like a simple concept. Seems like a really nerdy computer science thing to do. It might be a little fun to like create an event bus, and it seems like maybe it would be very straightforward. The devil's in the details. They're very complicated. The same goes for distributed logging. I recommend this library called Seek. It does a lot of really great things that make distributed logging work really well. One of those things is it works really well in a disconnected environment. So if you have services that are kind of going up and down, whenever they come back, they'll catch back up with their logging, and all of that logging will be kind of merged for you by Seek. If somehow Seek loses connectivity with its storage, it's going to be fine for a little while, queuing that stuff up and then syncing it back up when it can. Another thing that it does really well is it allows you to use all kinds of different tech stacks. I mentioned this earlier that it's kind of a bad thing to actually tie yourself into a whole tech stack. or to, write libraries that are in, let's say, .NET, because I'm a .NET person, that then you say everybody has to use this, this framework library that I wrote on their microservice. The reason that's a bad thing is because maybe .NET isn't the right technology stack to use for every one of the microservices. And so Seek solves this by basically having support for every tech stack you could possibly imagine. So if you have a .NET team, a Java team, a Node team, a Go team, doesn't matter. They can all use Seek, and all of your different modules will be logging consistently together through Seek. So definitely check that out if you want to do distributed logging in your application, which I highly recommend, by the way, because otherwise it's impossible to debug things. Synchronous communication. This is a really common mistake that I see. Anytime you have those red arrows that we've been talking about between your services, it's really tempting to have like an order service where maybe the customer is ordering and they send in their customer ID and they send in a bunch of details about the order. And you think, gosh, I sure would be nice to just look up the customer ID. I know it's already in the customer's microservice, so I'll just have the order service go hit the customer service, and using that customer ID that was passed in the order, look up the customer's data, come back with that customer data, and go ahead and finish, creating the order. This has a couple of pretty big problems with it. One of them is what's called a time coupling. And so if you imagine that the entire time the order service here is waiting right here for the customer service to read the customer and send it back, that order service is just spinning and it's not doing anything else. If the customer service gets slow under load from other uses, now the order service is slow too, because now the order service can't even do its own thing while it's waiting for the customer service. And the worse the customer service gets, the slower the order service gets. Now, if you imagine these kind of connections happening all around the application, then you really get a picture of of that example story I told you at the beginning, of how one service gets slow, which causes another 3 to get slow because they're using it. And then those 3 are slow, so they cause 5 others to get slow because those 5 others are using them. And round it goes until the whole application is slow just because of one module that started slow. So we really don't want these connections between our different microservices. The other problem here is an uptime problem. So if you imagine that the customer service goes down for maintenance, if I have truly independent teams, the customer's API or customer's microservice should be able to go down for maintenance whenever that team decides that they want to do that with their uptime guarantees. If the order service is using the customer service, well, the customer's service being down just broke the order service, and now the order service is down too. So we don't really ever want to couple things in this way. So this is a good time to kind of call out this big trade-off that we want to keep in mind. Microservices are really good at high availability and really bad at immediate consistency. If you want immediate consistency, you should probably build a microservice, which is really good. I'm sorry, a monolith, which is really good at immediate consistency and not as good as high availability, because if you want to even update just the text on a button, you probably have to take the whole application down for a few seconds while you're updating the entire app just for that button text. So not as good at high availability, not as good at frequent updates, but very good at immediate consistency. If you're trying to build microservices, make sure you're okay with that eventual consistency because that's the trade-off with that high availability. The next one that is a common mistake is shared test environments or components. So if you imagine you're mocking a customer service, you don't want to have that customer's mocked service be available to multiple different microservices, like an order service and an account service. The reason is if there's any kind of bottleneck in that customer service, whether it's a backend system or something else, now when you're writing, when you're testing, I should say, your order service and your account service, you're going to potentially impact each other's results. If you're going to mock something, you want to mock it a completely separate mock for each and every service that's utilizing that. So that's an important distinction to keep in mind. Problem number 10 is not automating your versioning and release. If you come to Trailhead and ask us, hey, can you help us build microservices? One of my very first questions is going to be, do you already have automated DevOps going on in your organization or with this application? If the answer is no, then I always say, let's start there, because if you're doing microservices, the whole idea is to be able to do lots of releases quickly and independently. And if you're doing that manually, it's very time consuming. It's very error prone. And I also like to add that versioning of your APIs is something that's good to think about. If you're going to be updating them very frequently, you want to think about how the versioning might work and what kind of support you want to have for old versions of your APIs and how you want to accomplish that. So those are two things to think about for sure that are part of the DevOps operations of your application when you're building microservices. Number 11 is mismatched team organization. There's this law, Conway's law, that says that any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. This was popularized in a book by Fred Brooks that you might have heard of called The Mythical Man Month. It's a pretty popular book in our industry, but it's a much older law or quote than that. And what it basically is saying is that an organization will often create something that is a shadow or a reflection of the organization's org chart. Example that's often given is if you have 4 groups that are working together to build a compiler, that they'll create a 4-pass compiler. It's just kind of built into the structure of the team, and that's what they're going to start. That's the structure of what they're going to create as well. How does that apply to microservices? Well, imagine you have a single team that's all trying to maintain all of your microservices, and they all just kind of pitch in where needed, and everyone's kind of swapping around as needed. Seems like a really flexible and fine way to do it, but what ends up happening is the microservices will start to reflect the organization of your team, and you'll start to get more interconnected and more monolithic like microservices, thereby accidentally moving it towards a distributed monolith. A better way to organize your team then would be to have separate teams that work on different parts of the application. Now, this isn't always strictly possible. So I have people ask me often, like, is it okay to do something like this where I have a couple of smaller services and we have one team that works on those? Yes, I think that makes a lot of sense. The danger comes in when you start kind of moving people around to different microservices all the time, and they really don't get that deep knowledge of that business area. And they also have knowledge of other parts of the system that it might be tempting to connect over to and steal some data from and start creating some coupling between the microservices. And the number 12 example of a mistake I've seen made is unencapsulated services. There's this concept called iceberg services. You know the old saying about icebergs that only 10% is above the water, the other 90% you don't see. And that's kind of how you want to design your APIs in general, whether you're doing microservices or not. But it can be very problematic if you don't do it this way, for microservices especially, because microservices are all about creating a high velocity of change. And as soon as you move that line down so that the API surface area that's publicly available and used is bigger and the implementation is smaller, now changes are going to have to happen on both sides of that line more frequently. And the idea is having that line be high, having your APIs be stable, your surface area of your APIs or your interface for your APIs to be very stable, and to be able to change that implementation a lot and frequently without affecting the interface. So keeping that waterline high designing very stable APIs with very small interfaces. That's the idea. All right, so just to sum up, if you're looking for a lightweight application for a single team, then a monolithic application might suit you best. If you're looking for a more complex, quickly evolving application that has clearly separated domains and high velocity, then you might be looking at microservices. Sam Newman says, don't try microservices unless you have a really good reason. If your only reason is scalability, there's lots of ways to scale monoliths as well. So be aware of the trade-offs, like immediate consistency versus eventual consistency, high availability versus downtime, potentially system-wide downtime in a monolith. All of those trade-offs, be aware of those and have a really good reason if you're going to do microservices. And then last, avoid these last 12 pitfalls that I've given you tonight, and hopefully that will help you not to build a distributed monolith. Lots of great further reading. There's a Sam Newman book called Building Microservices. That's a pretty good starting point. This cloud native architectures and building evolutionary architectures are also really useful books. If you're interested in the database side of microservices, this refactoring databases has some good content in it. And then if you're looking for something free, this ebook from Nginx called Microservices from Design to Deployment is another really great resource. Martin Fowler is a great person that is kind of an expert in this field. So his website has a couple places you can look for microservice information. I'm a .NET developer. Microsoft has some really good guidance on this as well. They have a architecture section on building microservices. And then they also have this eShop reference app that they've built using containers, using Docker containers and a bunch of other Azure services that are very microservice architecture and help you to see how you would do that on Azure through a reference implementation. So those are great resources. All right, so we talked about what these things are, about the 12 most common mistakes that I've seen, some further reading for you. That leaves us with just the Q&A to do. And I'll just mention this link one more time before the end, see if we can get up above that 200 before the end of the talk tonight. So that's bit.ly/whisk-water. So make sure you check that out if you haven't yet. All of these slides, by the way, are available at this GitHub link. I'm available at all of these places online if you'd like to contact me afterwards, whether it's about what we talked about tonight or about using Trailhead services. Be happy to talk to you about any of that. So my understanding is that there's an opportunity to chat on the different platforms that everyone's watching this on. So if you do have questions, feel free to enter those in the chat. And maybe we can see if anyone has any.
Yeah, thank you. Very nice talk.
Yeah, absolutely.
Feel free to put in your questions out and we can answer them live. I'll move the question and answer so they can see the GitHub link.
Sounds good.
All right, I guess that's a wrap then. I really appreciate everyone coming. See you next month when we talk about building your .NET services using gRPC.
Yes, I hope that was useful, everybody. Thanks for coming tonight. Appreciate your time.
Bye.
All right, bye-bye.